Okay, let's take a look at this example. It says, consider f of x equals 2x minus 3 all over x squared plus 2x minus 3. Show that the derivative, f prime of x, looks like this, and then draw its sign diagram. And then once you draw the sign diagram, find the intervals where y equals f of x is increasing or decreasing. Okay, so this is a kind of a strange rational function. We have a pretty complex one actually, okay? Notice that the bottom is factored neatly, so that helps us find the vertical asymptotes, and this the top is also factored neatly, which helps us find the zeros. Okay, so in order to do this problem, we actually need to be able to find critical points, namely critical points being the zeros of the derivative and the vertical asymptotes of the derivative. So where is the derivative undefined, and where is it equal to 0? Okay, so that's what critical points are. We need to find those first in order to draw the sign diagram, right? We've done sign diagrams before, and we're now just doing the sign diagram for the derivative. Not for this, but for the derivative, okay? Alright, so let's get started. The first step is to take the derivative of this. We could probably just do that by using the quotient rule, right? F prime of x is going to be the derivative of, or let's just put v, the bottom part, is going to be the same on top, x squared plus 2x minus 3, okay, times the derivative of the top, which is 2, okay, minus the original top function times the derivative of the bottom function. So that's 2x plus 2. And all of that divided by the bottom squared, right? So the bottom is x squared plus 2x minus 3 quantity squared. Okay, so that's my derivative using the quotient rule, right? So I'm getting a little bit closer to this. Now I just need to factor this and get to this expression. Okay, so if I go ahead and let's distribute. Okay, if I distribute this out, I get 2x squared plus 4x minus 6, and if I do FOIL on that, I get 4x squared minus 2x minus 6, right? Okay, and then the bottom there, we can actually factor the bottom. Okay, 2x squared, because I don't want to make it more complicated, why not just see if we can factor this first and then distribute that exponent. Okay, and that's what we can do. If I take x squared plus 2x minus 3, I can factor that, okay, into two little factors here, x and x. That's a 3, so that would be 3 and 1. That's minus, so that the signs have to be different, so that would be plus 3 minus 1, because that's plus. Okay, and there we go. We're really close to this. Okay, if I go ahead and simplify this whole top part, I get 2x squared minus 4x. That would be minus 2x squared. If I this part plus 4x minus or plus 2x would be, plus 2x would be plus 6x. Okay, and minus 6 minus negative 6 would be just 0. So that part would cancel out. And then this part, we can actually distribute this now. We get x plus 3 squared and x minus 1 squared. Okay, and then we can factor the top x out, and we're done. We can factor out a minus 2x. Okay, all right. So this is the function, and now I just need to draw the sign diagram, right? Okay. So how do I draw the sign diagram? Well, the sign diagram requires zeros. I need to have some points on here, zeros and VAs first, right? Okay, so what are the zeros of this? Well, zeros occur at x equals 0 and at x equals 3. Okay, what are my vertical asymptotes? They occur at x equals minus 3, right? And there's a double root there. And this one at x equals 1. Okay, so let's go ahead and draw that sign diagram. The sign diagram would look like this. I'd have a 0 here, I'd have a 1 here, I'd have a 3 here, and I would have a negative 3. So I have 4 critical points, 2 of them being zeros and 2 of them being vertical asymptotes. Okay? If I put in a negative number less than negative 3, okay, if I put like negative 4 in here, and a negative 4 in here, a negative 4, and negative 4 in here, you're just going to have to test this, okay? You would get a negative here. Between negative 3 and 0, if I put, for instance, negative 2, and I put negative 2 into all of these, I would get a negative. If I put a number between 0 and 1, for instance, 1/2, if I put 1/2 in here, the sum sign of that would be a positive. And from 1 to 3, I would get positive, and from 3 to infinity, I would get a negative, okay? And this is what the sign diagram would look like, okay? So now we can say, looking at this information, what the increasing intervals and decreasing intervals are. So this is the answer. This would be the answer to part A. Since we are asked to find the intervals of increase or decrease, now we can use our information here. So the intervals of increase would be from 0 to 3, right? From 0 to 3 would be increasing. But we would want to separate that out, okay? So we could say from 0 to 1, okay? Since 1 actually is a vertical asymptote, since this is actually a vertical asymptote, that's not going to be defined. Since these two are not defined, the f prime of x is not defined at these 2 points, we will actually leave those open, okay? And then from 1 to 3 would be my intervals of increase. My intervals of decrease would be from minus infinity to negative 3, okay, open. From minus 3 to 0, closed, because that's possible, okay? And then also this interval right over here, we would say from 3, and that would be including, because that's a 0, to infinity, open. Okay? So those 3 values would be, those 3 intervals would be my intervals of decrease, and these 2 intervals would be my intervals of increase. All right?